Today we're going to learn how to use LabView. We will cover how to open LabView, how to insert a DAQ assistant, how to plot the DAQ assistant data to a graph or an indicator, how to control the DAQ assistant with controls, and then also what is the front panel and block diagram of the software, as well as opening and saving VIs. So to start LabView, you can double click LabView icon on the desktop, or under Start Menu, All Programs, if you scroll to the top, you'll see LabView 2014. If you don't have that there, then scroll down to National Instruments, then to LabView 2014, and you can double click it there. I'll just start it from the desktop. Once LabView is loaded, you'll see this following window. This asks you if you want to open an existing file, create a new file, search for a file. You can also do the same things in a file menu. The easiest way to create a new VI is by clicking blank VI, or by using the shortcut Control-N, which is what I'm going to use. When you do that, you have two windows that pop up. One is the front panel, shown here on the right. The other is the block diagram, shown here on the left. The front panel is where you insert all the indicators and graphs for using them. The front panel is basically the user interface. This is where you insert all your indicators and controls, indicators such as graphs, meters, dials, etc., and controls such as the mirror controls, buttons, LEDs, and etc. The block diagram is where you actually put the bits of code that are represented in a block. So when you insert a DAQ assistant, it's actually inserting a code block for that specific function. And then you connect the blocks together, so you connect your bits of code together with a wire. And it tells the data where to flow. So you tell the data to go from the DAQ block to the whatever block you're looking at, such as an indicator block. So to start off with, I'm going to show you how to insert a graph. So to access the controls for the front panel, you right click on the front panel and that'll bring up the controls palette. You can also go to View and Controls palette to bring this up. Graphs are underneath the graph folder. You click on that and you'll see it's shown here. Now there's two types of graphs you'll be using. There's a waveform graph and a waveform chart. What a waveform graph is it'll only show the last available set of full data that's collected to display, whereas a waveform chart will take the previous data and then add on the next set of data. So the chart basically will give you extended period of data collection. So if you want to collect over time but you want to sample at like a second, so like one sample a second, and you're reading one sample and you want to keep on plotting that on a waveform chart instead of a waveform graph so that it doesn't keep on disappearing the data, or disappearing the data, then you can use a waveform chart. Manually, you'll be using a waveform graph, so you go ahead and click on it, hold, and drag it into place. And you notice that the waveform graph shows up both on the front panel and the block diagram. Now, on any indicator or any control, you can click the label at the top here by double-clicking it. You can change the name, so I can change this to voltage plot. And then click off of it. And you notice that it changed that label on the block diagram as well. This is important since you don't want to get confused about which graph you want to plot what where. Now, if you look at the graph itself, you can change the y-axis and the x-axis labels by just double-clicking like you did with the labeling of the whole entire plot. So I'm going to change this from time to voltage just to show you how you do that. And once you type it in, you click off it, and then it will save it. Now, the x-axis and y-axis on these waveform graphs are default set to auto scale. So if I right click on the x-axis, you notice that auto scaling is checked, which this means is that when you collect data, it will automatically scale the x and y axis so you can see that signal. Now there's sometimes you don't want to have this happen, so what you can do is click on the y-axis or the x-axis, right click it, uncheck auto scale, and then now you can change the limits. So I could change this limit to 0 and then change the top limit to 100 by double clicking and then typing in the value. And you notice that it automatically adjusts the intervals. Now when I hit run, it won't change that scale based on the signal. But if I add an Y auto scaling and I hit run and collecting data, it will automatically change that 100 and 0 to the proper range. So keep that in mind when you specify the limits and then you go to collect your data and you have auto scale checked, then it's going to automatically rescale the y-axis or x-axis. Now I'm going to show you how to insert a control. You can right click on the front panel to get the controls palette again. I'm going to insert a numerical control. Now what this does is when I click run, whatever value this is and whatever is connected to this numerical control will be sent through to the program to wherever it's connected to. And it'll only do that when you hit run. So if I change the value to 100 and don't hit run, then it's still going to be the old value and it hasn't set that value through yet. Now I'm going to try and connect the numerical control to my waveform plot, which is not possible. It'll give you an error, and you can see that it's showing you here that you can't connect this wire, you can't connect these two together, and it'll also show you here that there's an error because it's not going to let you run. Now when you hover over it, it'll tell you the reason why there's an error. So this is a broken wire because it's not a solid wire that's actually connected. To get rid of these, the shortcut is Control B to remove all wires. You can also highlight it and hit the delete button. Now to show you how the controls work, I'm going to right click and I'm going to insert a numerical indicator. And then I'm just going to connect the control to the numerical indicator. So now if I type in 10 and hit enter, you notice it hasn't updated the value in the numerical indicator. But if I hit run, it updates that value. So if I type in 100, enter, you notice the value isn't updated until I click run. Now if I hit run continuously, this is where I can automatically change the value because it's continuously running. And I have to hit stop to stop running it continuously. So this is how you insert controls, an indicator, and a graph that you'll be needing to use. Now there are many different types of controls and indicators that you can use. You can see here underneath the numeric that there's like a meters, gauges, dials, knobs, tank, thermometer. And then under Boolean you can see all these LEDs and push buttons and toggle switches. And there's many other options that you have. It's pretty much limitless, but you can go through that yourself. So now to remove stuff, once you put it in and you don't want it anymore, you can click and drag on the block diagram or the front panel across the area you want to delete and hit the delete button. And then you notice it deletes everything. So now we're going to learn how to insert the USB DAQ, and to do this you must have a DAQ hooked up to the computer. So to do this, you're going to click on your block diagram, right click to bring up the functions palette or view functions palette. And then you're going to scroll down to Express. And you're going to go to Input and DAQ Assistant. Then you're going to click and drag it in, place it in there, and then it's going to initialize that DAQ Assistant as you show there. Now keep in mind you must have a DAQ connected to the computer in order to successfully insert the DAQ Assistant. Now once it's initialized, it'll notice that you have you have acquire and generate signals. Now the USB DAQs we have are only a 4-channel USB DAQ that only accepts analog input. So we're going to only be able to acquire signals and only be able to have analog input. And you notice that you see voltage, temperature, strain, current, etc. There's many different options. You'll mainly be using voltage, temperature, and strain, and maybe a few others depending on the labs that you're conducting and how they're set up. So we're going to go ahead and select voltage for this. And once you select what type of signal you want to acquire and what type of analog input what type of signal you want to acquire, now this is where you select your DAQ. So the DAQ I have connected is an NI9215BNC DAQ. You're going to select the channels. You see the channels for that DAQ. You see all 4 channels there. And if you remember from the DAQ video, these are the AI0, AI1, AI2, AI3 channels, which correspond to the 0, 1, 2, and 3, below the ports on the actual DAQ. Now, if you want to select just one channel, you just click that one channel and then hit finish. If you want to select multiple channels, you can hit shift to select all 4 channels if I click this bottom one, or just the top 2 if I click AI1. You can also use control to skip one and remove one without having the other. So I can have AI0 and AI3 channels selected at the same time. I'm just going to select AI0 for now. You hit finish. And then you get the DAQ Assistant menu showing up. Now this is where you specify how you want to sample it and what type of voltage range you're looking at, because that's what you specified you're reading. Now you can add channels from here by clicking the add button right there, and you can tell it what type you want. So I'll add in a voltage, and I'm going to say AI1 because I already used AI0 channel. And now you notice it shows up a voltage _0. You can also remove channels from this menu by selecting the channel first. Say I want to remove this one, and hit the X button. It'll ask you if you really want to delete it, and you hit yes. You can also change the channel that a specific, like this voltage _0 is associated with by clicking this button, and I'll change it back to AI0. Now, underneath here, you specify the signal input range. Now, for the DAQs we have, the signal input range is plus or minus 10 volts, which is automatically set here, so you'll leave that the same. And then if you look at the terminal configuration, you'll notice it sets a differential. What differential means is that it takes the voltage difference between AI0 plus and AI0 minus, and this is the type of port you'll be using. You don't have to worry about the other ones. Now under acquisition mode, you'll notice there's 4 acquisition modes. We'll be using the bottom 2 acquisition modes, N samples and continuous samples, depending on which lab you're using. What N samples means is that it's going to collect only 100 samples at the rate you specified and then stop. It won't collect anything else until you hit the run button again. So when you hit run with N number of samples, then you go and collect 100 samples for a rate of 1,000 hertz, and then it will stop collecting that data. And if you hit run again, it will collect that data in the same amount, in the same way, and then it will rewrite over that graph. Now, the way continuous samples works is that when you select continuous samples, it will keep on collecting data until you tell it to stop by hitting the abort button or by some other condition that you specify. Now, the way that continuous sample works is that it will collect 100 samples, like here, as shown based on what we have here. It'll collect 100 samples at a rate of 1,000 samples per second, which means that it'll only collect data for 1/10 of a second. And then it'll display it, then it'll collect another set of data, and then display it, and keep on going until you tell it to stop. So, for this first lab, you'll be needing N samples. You can also use continuous sampling, but it's up to you. Mainly, N number of samples is easier to work with, then you don't have to worry about keep on writing over your graph multiple times. That way you can specify when you hit run to collect the data, and then once it's done collecting data, display it to me. Now, there's one last setting you need to know about, and that's under Advanced Timing tab, here shown as timeout in seconds. What this is it means how long should the DAQ wait before giving an error for data collection not being complete. And that is 10 seconds right now. It's set to 10 seconds. Now, if you're collecting 30 seconds worth of data, you can't leave this at 10 seconds, otherwise you're going to get an error, kind of like when you try and open a web page that's no longer existent, and it'll tell you, there's no response and the request has timed out. So this is kind of the same type of deal and the same type of error you'll get. So if you're going to collect 30 seconds of data, you at least need to make it like 31 seconds for timeout, so that you give the DAQ enough time to collect all your data for that 30 seconds, and then you won't get that error. Now, if we go back to the configuration tab, we have all our settings we want to set up. Once you have your settings set in there, click OK. And then you'll notice it's going to create the VI. And it'll say building VI. And then once it's done, we can continue. So now it completed building. And you notice that you got a data output here. We want to create a graphical indicator for that so we can see what the DAQ is reading. You can do that by going to the front panel, right-clicking, going to Graph and Waveform Graph, dragging and inserting it. And then you notice it shows up on the block diagram. You can move blocks on the block diagram by selecting it and dragging it. And now I need to collect the data output, tell it that I want to go to the waveform graph. To do that, you click on that little triangle right here by data, and then connect it to the waveform graph. And you notice it created a wire. So this is a wire. A wire tells the system, send the information from this DAQ through this wire to this waveform graph. So you can think of it kind of like a circuit where electrons will flow and light up a light bulb when it's connected properly. This is exactly what's happening here, except it's not electrons, it's the flow of data. So now I can hit run, which tells the system to acquire data at the rate and number of samples you specified, because we're using in sampling, and then display it. And you can see here we have our results. Now, say I want to change my rate and change the number of samples. I have to open my DAQ, and then I have to go down here and change it to, say, 1,000, and then hit OK, and then wait for it to build again. And then I can collect my data again. But this is time consuming. So I have to hit run now, and then you can see that it run it and shows the results. But it's time consuming to keep on having to double click on that, bring that menu up, changing the rate, changing the number of samples, clicking OK, waiting for it to build, and then collecting data. So the easiest way to be able to modify the information about this, or modify your number of samples, your timeout in seconds, and your rate, is by creating controls for that. To do that, you can either hover over these little triangles for what you want to create a control for, timeout, number of samples, and rate, or you can click on the DAQ to where you see these little squares and drag it like you're resizing a picture. And then we can right click on, say I want to create a control for the number of samples, right click on it, click create control, and you notice it'll automatically create the proper control with the number of samples labeled on it, and it also shows up in my front panel. And then I'm going to do the same thing for rate and timeout in seconds. Now you notice that I can now control those values that I used to have to double click, wait for it to show up, type it in, click OK, wait for it to build, and then go back through it all over again. So now this is very powerful. I can change this to 100, and it's only going to collect 1/10 of a second, so I should see 0.1 at the end, which I do. Now I can change this to 200 rate instead of 1,000, and then click run again. So now you can see how this time savings really helps. And you can also change the timeout in seconds. So this is pretty much all you need to know for right now. This is the end of the first tutorial. The last thing we're going to go over is saving the file. To save the file, you go to File, and you can click Save, and then save it as the file you want. But for better practice, it's better to save the file for previous version. The main reason for saving for a previous version is that LabView 2014 can't be opened on LabView 2011. So a file saved in LabView version 2014 cannot be opened in LabView version 2011. So a way to counteract this, because many computers may have different versions, you can save for previous version. Then you can specify what version you'd like to save it for. I would choose like 8.2 or 8.0. That way you can open it on pretty much any computer around, since they'll most likely have the version that is later than that. And then you click Save. And then it'll ask you where you'd like to save the folder. You click Save. And then it'll save your file. And then when you're done, you can exit out. I'm not going to save unsaved changes because I already saved it as an earlier version. And once you close out of that, you get your original LabView window asking if you want to do anything else. To close completely out of LabView, you hit that little X. We covered how to open LabView, how to create VIs, how to save a VI, how to insert a DAQ assistant, how to create controls, how to create indicators and graphs, and then use those indicators and graphs and controls to control our DAQ and get our information from a DAQ on a computer screen.